Given question, find the thermal stresses developed in nut and bolt arrangement when first both the ends of the bolt and tube are rigidly connected. Second, both the ends of the bolt and tube are fixed with nut.
Let us understand how to calculate the thermal stresses developed in nut and bolt arrangement. First case, when the copper rod and steel tube are rigidly connected at their ends. If we observe the given data, then rise in temperature T2 minus T1 is given 200 degrees Celsius. As the temperature rises, that means this copper rod as well as steel tube is getting expanded. Now if we observe the values of coefficient of linear expansion alpha, then the alpha for this copper is greater than alpha for the steel. So we will show here the change in length, or we can say increase in length. As the value of alpha is greater for copper, I will show increase in length for this copper is greater than the steel. Now we will show the increase in length for the steel. So it is less than the copper. But the condition is given that the two ends, that is for the copper rod as well as steel tube, are rigidly connected. That means for these two materials there is common increase in length. So we will show here the common increase in length. Now what is happening here? When the temperature rises T2 minus T1 200 degrees Celsius is taking place, that time this copper material will try to pull this steel material. So here there is the extension is taking place for the steel material. So we will show here with the help of arrow. So this copper material will apply the force so that the steel material will extend, and here is the common increase in length. At the same time, this steel material will apply the force in opposite direction on this copper material. So there is the contraction in the length of the copper tube. So we will show the direction of the force applied. So on copper this compressive force is applied, and on steel this tensile force is applied. And finally these two materials will increase up to this common length. So this is the common increase in length. Now why this process is happening? Because the two ends are rigidly connected. So because of this condition there is common increase in length. So if we observe, area of the copper is given, area of copper rod is equal to 7 times area of the steel tube. So this condition is given, as well as length of the copper rod is equal to length of the steel tube. We will consider it as a L. Now to find out the stresses developed in the copper rod and steel tube, we will prepare one table. So first is steel and second is copper material. Now here we have to write the value for thermal expansion. So thermal expansion, how to write? So we know that this value of coefficient of linear expansion multiplied by change in temperature multiplied by original length. That is the value of thermal expansion. So we will write this value for steel as a alpha S multiplied by change in length T multiplied by original length as a L. Then for copper rod we will write as a alpha C multiplied by change in temperature T multiplied by original length L. So here LC is equal to LS is equal to L because the length is same. Now we will find out the mechanical expansion due to applied force P. Now if we observe here the tensile force P is applied. and here the compressive force, that is also equal in magnitude. So if we observe, these forces are opposite in direction but equal in magnitude. So what is the expansion or contraction due to this P? Now in case of steel it is expansion, and in case of this copper it is contraction. So how to find out? Now we have formula, that is E, Young's modulus E is equal to stress by strain. So I will write here stress sigma divided by strain. Now this strain is equal to delta L by L. Now we have to find out this change in length. So how to write this? So we can write here delta L is equal to sigma L divided by E. So we have to write this equation. So I will write here, for steel we will write sigma S, that is the stress in steel, multiplied by length. So original length is same, that is L, divided by E, Young's modulus for steel, that is ES, and for copper sigma C L by EC. Now this is the stress developed due to applied force P. So how we can define this stress? So we know that stress sigma is equal to P divided by A, that is P divided by cross sectional area. Now if we observe, the applied force P is same for copper as well as steel. So how we can write here? So we will write here P is equal to sigma into A. So I will write here P is equal to sigma for copper, that is sigma C AC, is equal to sigma for steel, that is sigma S AS. Now we have relation. AC is equal to 7 times AS. So we will put here. Therefore sigma C into 7 times AS is equal to sigma SAS. Now this AS is getting cancelled on both the sides. So we can write here sigma S is equal to 7 times sigma C. So this is the relation in between stress in the steel as well as stress in the copper. So this is applicable only for stress developed, or we can say change in length due to applied force. So this mechanical force P. So we have to write here this relation. Now we will put here sigma S is equal to 7 times sigma C. Now we will move to the next step. So this is the first step, that we have to prepare table. Then second step, we have to develop the relation in between sigma S and sigma C. And then the third step, we know that from the diagram, final expansion in steel is equal to final expansion in copper. So if we observe, this blue vertical line is the final expansion. So how to write this final expansion? So with reference to this diagram, final expansion in steel. So here is the steel tube. Now if we observe, thermal expansion is for steel tube is up to this length, from this length to this length, and then mechanical expansion is from this length to this length. So here if we add the thermal and mechanical expansion, then we will get the final expansion. So we will add these two values for steel. So for steel we will add alpha STL plus sigma SL by ES is equal to final expansion in copper. Now for copper, if we observe, final expansion due to thermal, it is taking place up to this length, and mechanical expansion, that is due to applied force P, is taking place up to this length. So how to find out the final expansion in copper? So if we take this thermal expansion minus this mechanical expansion, then we will get the common or final expansion. So thermal expansion is alpha CTL. So we will write here alpha CTL minus mechanical expansion, that is from this point to this point due to compressive force P. Here is the, now we will not say here expansion expansion but the contraction due to P. So in this case, mechanical contraction is from this point to this point is equal to sigma CL by EC minus sigma CL by EC. Now if we observe, L is the common term on both the sides. So we can take here common and we will cancel. So if I cancel this, so simplified form of equation alpha S T plus sigma S by ES is equal to alpha CT minus sigma C by EC. So we have relation in between sigma S and sigma C. So we will put the value of sigma S is equal to 7 sigma C and we will transfer this term to the left hand side. So 7 sigma C by ES plus sigma C by EC is equal to alpha C minus alpha S and T is the common term. Now we will solve this by putting the value. So we have to find out the stress in copper as well as steel. So here 7 sigma C divided by ES. So value of Young's modulus for steel is given 2 into 10 raised to 5 Newton per millimeter square. So here important term is the unit. So Newton per millimeter square is the unit plus sigma C by EC, that is 1 into 10 raised to 5 Newton per millimeter square is equal to. So here we will take 18 minus 11 and 10 raised to minus 6 common term multiplied by value of T is 200. Now if we observe the denominator, here we will multiply and divide with 2 by 2. So here it will become 2 into 10 raised to 5. So this common term we will transfer to the right hand side. And here 7 sigma C plus 2 sigma C, that is equal to 9 sigma C. So if we solve this right hand side and we will calculate the value of sigma C, it is 31.1. But the value of ES and EC is Newton per millimeter square. So we will mention here the same unit. So for sigma S is equal to 7 times of sigma C, that is 217.7 Newton per millimeter square. We will move to the second case when two ends of the copper rod and steel tube are fixed by the nut. When the increase in temperature is taking place, then there is the free expansion in the copper rod and steel tube, and that's why there is the increase in length. But this increase in length is getting prevented by the nut because the nut is tightened at both the ends. So we will first show the increase in length in the copper rod and steel tube. So if we observe the value of coefficient of linear expansion, then it is greater in copper. So we will show here the free expansion in the copper rod. We will show in the form of dashed line. Now this is more than the steel because for steel value of alpha is less. So for steel also we will show the free expansion in the steel. Now if we observe, the ends are fixed with nut and this expansion is getting prevented by nut. So the force P is applied in opposite direction. So we will show here the mechanical force applied by the nut. And this force value is P. Now due to P, this extension is getting prevented. And there is no any extension is taking place in copper rod and steel tube, and that is the reason why the stress is developed in these materials. Now we will prepare one table. For steel and copper, these two materials, first we will show the value of extension due to thermal energy or increase in temperature. So here is the extension. So for steel we have to show the value. So how to show? We know the formula, that is value of alpha multiplied by change in temperature T multiplied by original length. For steel we will write alpha S T L. For copper we will write alpha C TL. Now this length is same for copper and steel tube, and this value of T is also equal, that is 200 degree Celsius. So this is the extension due to thermal energy. Now this change in length is getting prevented due to mechanical force P. So what is this change in length is prevented by P? So how to find out that? So we have formula, that is, we know that Young's modulus E is equal to stress sigma divided by strain. Now this strain is equal to delta L by L, sigma divided by delta L by L. Now this stress is due to this mechanical applied force P. So we know that how to write the value of delta L. So delta L is equal to sigma L divided by E. So we have to write this formula for steel as well as copper. So this extension is getting prevented due to P, and this sigma is equal to P by A. And that's why we will consider this sigma. So I will write here sigma S multiplied by L divided by ES for steel, and the copper sigma C multiplied by L divided by EC. Now if we observe, this applied force P is equal for both copper rod and steel tube. So how to write this? So we can write here P is equal to sigma A. So I will write here P is equal to sigma A. So this copper rod we will write sigma CAC, and it is also equal for sigma SAS. So I will write here P is equal to sigma CAC, which is equal to sigma SAS. Now the value of AC is given, it is 7 times of AS, that is A is the cross sectional area. So cross sectional area for copper is equal to 7 times cross sectional area for steel tube. So we will write here, so we will put this value sigma C multiplied by 7 times AS is equal to sigma SAS. Now this AS is getting cancelled, and therefore 7 times sigma C is equal to sigma S. So this is the relation we will get for the stress developed in steel and stress developed in copper. In this case, total change in length delta L is getting prevented by the mechanical force P applied by this nut. So we will write the formula as delta L due to thermal energy is equal to delta L prevented due to mechanical applied force P. So we have to write this value with reference to this table. So what is the total change in length due to thermal energy? So here we have to add these two values for change in length in steel and copper. So we will write here alpha S TL plus alpha C TL is equal to. Now what is the total change in length prevented due to this P? So we have to add these two values, that is sigma S L by ES plus sigma C L by EC. Now if we observe, L is the common term. So if we take the common on both sides, then it is getting cancelled. So we will cancel these. We will write the simplified form alpha ST plus alpha CT is equal to sigma S by ES plus sigma C by EC. Now we will take T as a common term on left hand side, and on right hand side we will put sigma S is equal to 7 sigma C, and we will put the value of Young's modulus for steel as well as copper. Now if we observe the denominator, then we will take here the common denominator. So we will multiply with 2 by 2. So if we multiply, then this denominator will become 2 into 10 raised to 5. So this 2 into 10 raised to 5 term we will transfer to the left hand side, and here 7 sigma C plus 2 sigma C, that is equal to 9 sigma C. Now this, if we solve here, then we will get the answer sigma C is equal to 40 Newton per millimeter square. So why this unit? Because this value of Young's modulus E is Newton per millimeter square. So we have taken as it is. So standard unit is Newton per meter square. So you can convert here this Newton per meter square. But if we take as it is, then we have to mention here the same unit, and then value of sigma S is equal to 7 times sigma C, that is 280 Newton per millimeter square.